That would be nice. We're going to try and finish chapter 6 ideas today on extended acid and base stuff. Today's topic is titration. I'll bring back out the burette. We talked about it briefly last time. It's used in titrations. We'll see why. Quick community service announcement for anyone that wants to today and tomorrow at lunch. If you have a container or 2 hands, you certainly could gather up donations for Herr Hood. Herr Hood is in the sport department sitting outside the office. And yeah, I don't quite know why he chose that. But anyway, that's where he is. So if you want to, I told him my people, if they wanted to, could gather up donations during 6th period, head over during 6th period and give it to Herr Hood as part of his Sammlung. He's going to send it through this Red Cross help for the refugees from the Ukraine. So it is a worthy goal. If any of you wish to help, you certainly would be encouraged to do so. Good. Okay. So for AP, again, while I'm gone, work on chapters 5 and 6. We're actually theoretically up to 6. So work on those. Ask me questions as you need to through email, and I'll try and get back to you as I can from the foreign country known as Austria. And I'll be back on like the 20th, I think it is, right? So 2 weeks from Monday. Good. Okay, questions from you first. I want to take that because I didn't do that last time. Any problems you'd like to ask about that you've been working on? This is your opportunity. And I better write with chalk. No? That's all right. As you wish. Good. Then I'll get to where we're beginning today. Last time we met, I threw a lot of stuff at you about buffers, and including the handy-dandy buffer equation, which you will get in some form on the given information for the AP Chem test. We made a buffer together. We also talked about getting a ratio for a buffer. And we talked about how to get a buffer if you only have one of the ingredients, right? You just change the one ingredient to, or half of it, to the other ingredient. And remind me, just to warm up your brains, a buffer is a and it's A buffer is, Tom? Yeah, and throw a little adjective in front of acid. Super, good. So weak acid and its conjugate base. And a typical buffer is half and half. But as we found out, you can tweak them and make them whatever pH you would like within reason. Ute. That's not on the AP anymore, so we're not going to worry about it. And Cheryl does enough of a job talking about indicators. I'm only going to tell you the 3 indicators you need to know. She gives you about 20,000 indicators. You don't need that many. So, indicators. There's 3, actually 3, but we'll say 4. The first one we did was universal, which is a combo, right, of several indicators. You might have heard that already. And universal indicator, it's red when it's in a, our guest might know. Universal, it's red when it's sitting in what sort of stuff? You remember from last year? Acid. Acid, right. And these folks just saw it the other day. Sitting in a base, it's, Sarah, what color? Blue. Blue. And then yellow, green, or neutral. I could spell neutral. The The problem with this indicator, to be really blunt, is the colors change gradually. That's not helpful for titration. So it's useless in titration due to gradual color changes. Okay. Then there's three that you want to know for AP chemistry. And it goes like this.
Mr. Weiss, can you see the far left side of the table?
Thank you. Sorry about that, Quinn. I'll move that around. Hopefully get that in the way. Out of the way, yeah. In the screen. There we go. Thank you, Aaron. Okay, Snooper folks, I'm doing a broadcast at home too for people that are at home. Yeah. Okay. So let me give you the three main ones. Methyl red. And that's if you got endpoint. We haven't had that word, have we? Okay, I'll give you that definition in a second. Endpoint of 5 to 6. And it's when you've got strong acid, weak base. Bromothionyl blue is got an endpoint at 7, and that's when you got a strong and strong.
Are the numbers referring to pH?
Thank you. Right, the numbers of the pH. And the final one is my favorite, phenolphthalein. How can you not love to say that? Can everybody say that for fun? Phenolphthalein. Doesn't it sound like you got like a speech problem? I love it.
M or an N?
Phenolphthalein. Phenolphthalein. Phenolphthalein is on the basic side. So it's talking like 9 to 10. And it's when you got a weak acid and a strong base. Now, here's the deal. An endpoint is the pH at which the indicator changes color. And I'm going to show you one here for phenolphthalein. And really it's the moment too, in time or in the titration. Like chemists will often say, at how many milliliters did you reach the end point? In other words, when did your solution turn color? After how many milliliters of whatever, of titrant, I guess we could say in chemistry language. So pH and moment in titration in milliliters when color change occurs. Okay, let me just grab something to test that with you quick. It's a cultural difference. You ever notice that?
Door open, this door closed policy.
Well, the best thing is we lock this door and it's at night behind 2 other locked doors. Oh, is somebody going to break open the locked door just to break open this lock? Never mind.
What's the pH at the top for? Is that endpoint pH? Just that it's
Endpoint.
in pH. my pH scale. Oh.
So off we go. I'm going to take and combine here HCl, solid soda, natrium hydroxide, so NaOH, so strong acid, strong base. Let's put a little base in here first in a flask.
Is that a strong base?
This is a strong base, NaOH, right? So there you go. It's clear, not a big surprise. A lot of all our strong acids and bases are clear as a solution. And I'm going to add a drop or two of phenolphthalein. Holy moly. You just need a drop or two of any indicator. I put in more than I need, but that's the way it goes. And what you're going to do in a titration is use a burette. Let's get that as a reminder. And well, first you're gonna get the air bubbles out. You're gonna do that by squeezing this thing back and forth, the burette. Oh, that's a really poor idea. So, come on. Jesus. Of course, I picked one that is stuck. Okay, well, that was a nice idea. Once in a while they get stuck, and it's hard to get them unstuck without breaking it. Okay. Floppity zweite.
Which one? Just. Yes, it is.
Ah,
Yeah, but I'm sure that it's strong. A base. So we base. I want strong base.
all right, I got one that theoretically works. So I'm going to fill this with some acid. So I rinsed this out already with distilled water, and now I'm going to rinse it with a little of the acid first. Why? Why do I let the acid kind of rinse through? Why don't I just fill it up right away? Hint, I just rinsed it with some distilled water. Why do I not just want to fill it up with acid? Ooh, think about it. Why, Tom?
Is it because when the acid mixes with the water, it'll generate a lot of heat?
Nope. It's not a safety issue. It's an accuracy issue. So why? No big.
Well, because there might be some residues, so your measurement will be including the water that you put in previous.
Exactly. There's water in there. What does that do to my concentration of the acid? It makes it decrease. So that's a problem. So you want to rinse out that distilled water first with some acid. So I'm going to do that. Luckily, it's a low concentration and I'm not going to use much. So just pour a little in and let that drain out like so. Okay, now I'm going to try and lock it. Hope it stays locked. And I'll fill this sucker. Okay, I filled above the highest line. Why is that a problem? Why is that a problem, Sarah?
You can't measure it?
I can't measure it, so I better get rid of some of that and get down in the lines. It doesn't matter where, but somewhere I've got to get down in the lines, okay? All right, now, I am afraid that this acid is too weak, so I don't know if this is going to work or not, but let's just give it a try. Because I'd like to show you a titration, even if I can't have a whole lab today, because we just don't have time. I'll try to show this. Maybe Quinn has done a titration already. I don't know. I hope so.
Can you explain just quickly what the point of the titration is?
The point of a titration is, one of the concentrations, you're going to use it to find the other one. And we use it with that M1V1 equals M2V2. So I think we wrote that sometime yesterday, but anyway, now you get the idea. And this one, of course, leaks, which is not really so great.
And the two things that we're comparing are usually acids and bases.
Yes, one's an acid, one's a base.
Is that
It doesn't
always-
have to be that, but it's that most of the time, and it's certainly that in all of chapter 6. So most titrations involving that. You could do an oxidation reduction reaction too, but something would have to have an acidic or basic quality because you've got to use an indicator to have something to change color so you can see what's going on. Okay, so there's my pink stuff. That's faded a little bit. It's a little weird. And now I'm going to add acid, but I got to write down where I'm at. And with my eyes, this is questionable. Your eyes are a lot better, but let's just do this. So 4, 3.5. So it's between 3.5 and 3. So let's make it 3 point. There's 3 point. So 3.5, 3.4, 3.3, 3.25. So 3.25 milliliters. So you can be pretty accurate to the hundredths place, which is cool. Okay, now I'm going to let this thing roll and swirl it until I get a color change. Yeah, you know what? Why don't you stand up so you can see this, or come around. Sorry I got to do it back here, but I'd like to at least show. So Quinn, we're adding base to my acid to get a color change. I'll try and show it to you here.
Will the color change be drastic or?
That's the cool thing. That's why I picked this. It's very drastic with phenolphthalein. That's why I picked this one. The other ones are a little harder to use. Okay, so. And there it goes. And I probably overshot it, but I'm going to write down what I got anyway. And notice now it's perfectly clear. So it definitely went from pink to absolutely clear. And you should be able, if you're good, to get it within like a drop. I obviously overshot it. But the first time you often do, and then at least you have an idea how much you need. So we're going to move that up a bit. And one of you come, and Sarah, come up and help me do this because you're going to see better than I. All right. So there's 20. So it's between 19 and 18.
That's 19. So it's
So-
19 point.
Yeah, like 19.
Oh, wait, is this that line?
Yeah, so that's 18, 19,
No, this
20.
is 19.
No, that's,
The 18's here.
oh, look around the corner. 18 point.
Yeah, the line's here.
I know.
So,
So on my screw up is this. It's not 19, it's 19.5 and 19.
Yeah.
So that's my problem. Sorry.
So I can't see which line that is meaning to go to that one. So
Okay,
it's
so
19.4.
yeah, so 19 and 19.5. It's hard, especially the first time reading it, because each one is different. You got to really figure out where the numbers are.
You're welcome for the moral support.
Yeah. And so 19 point.
I think we have to
for something, and you're gonna have to use your eyes and estimate what.
Like 19.5 here goes to this
No,
line.
that's not helpful.
Is that for
Thank you,
this
Peanut
line?
Gallery. So I think that 19.5 line is there. So it's above that quite a bit, and the 19 line is
Why
like
would they
here.
do that? 19.6.
So you had your,
19 point.
no, it can't be that because 19.5 is here and 20 is down there. So it's what Sarah's finding that's hard is it's the opposite direction from what you think. It doesn't get smaller as you go down, it gets bigger. So, well,
Dramatic.
it makes it hard to do.
It went from 325 to 19.
I would say like 19.25.
2.5, I like it. Okay, thank you. Now look at this, it's odd because what we have is then my values 19.25, that's the final. So it's the final minus the initial, if you think about it. So you guys can do that in your head, right?
16.
Look at the significant figures, 4. In other words, this instrument called a burette is super accurate, super duper accurate. Let's now do the math for the titration. So here we go. Let's say we had, well, there we did. It's 1 molar NaOH. So my chemicals were NaOH, 1.0 molar. And HCl, they said it's 6%, but we don't usually use percent, so I have no idea what it is we're going to solve. Okay, but I used for the HCl, that was what I had up as my titrant. So my titrant was that much. So HCl, 16.00 milliliters. And the NaOH, I used about, let's say 50. Let's say I was super accurate. So we'll make that up, 50 milliliters, okay?
Wait, where does the 50 milliliters?
Where? We subtracted and got them. This is the one we subtracted just now. And that's the 16.
But the 50.
I made that up. I estimated what I put in the little flask to begin with, Noah.
Oh.
I put in some NaOH. I didn't measure it because I don't have the time to do it with you. But I wanted to give you some kind of number so we can do a quick titration with this. Okay, here we go. Again, we're going to use a formula Cheryl doesn't like, but I like it. And I gave it to you last one. Na times Va equals, Lena?
MB times MB.
Good. And the B's and A's, Lena, stand for
Acid and base.
acid and base. So we can do this because what we got, to help my Schnipper friend here, is we got the number of moles of acid on one side. Once I get to the end point, right, the point where the indicator changed color, once I get to that point, if I really hit it exactly, then the number of moles of acid at that point equal the,
Number of moles of base.
thank you, Circle. That's the whole trick, as it were, of a titration, okay? So let's throw some numbers in. So for my acid, I had, I don't know what the concentration is, but I had 16.00 milliliters. And you might say, I don't have to change it to liters. No, not if you keep them both in milliliters. Beautiful. So, and on the other side, we had 1.0, we'll say 00 to be nice, keep four sig figs, molar NaOH times 50.00 milliliters of my base. And that we can pretty well do in our heads, can't we? Look at that. 1 is easy. So the concentration of the base I just divide 50 by, you got it. So 16. Can you do about do that in your head? Double both numbers.
Get like 3 point.
Yeah, 3 point something. Okay, so okay, that may be a calculator. All right, it's not quite exact. So somebody punch it out. 50 divided by 16, 3 point. Lena, you got it already?
3.125.
3.125. Nice accuracy, thank you. And the concentration is going to be in what label at the end of the day, everybody? No B? Molar. And if you think about it, it kind of makes sense because I really did put around 50. I put a fair amount of base in there, and we used less acid than I thought. It's actually more concentrated than I thought. In fact, it's about 3 to 1, isn't it? It's quite a bit more concentrated. Here's a quick practical thing that you'll do a problem on at some point. When you use I hope you don't get to this point, but if you get caught drunk driving and you have to breathe into a breathalyzer, the breathalyzer checks the alcohol content of your blood using a titration. It's an automatic titration the machine does. And it essentially does the same mathematics automatically to figure out the blood alcohol content. So titration can be useful. All right, no D, then no B.
2 things. Is that something we established earlier, that if the moles of the acid equal the moles of the base, then the solution is neutral?
That's right. No,
Or
then the solution has hit what's called the equivalent point. And now we're going to talk about that today and why we can't say it's necessarily neutral. Up until this class, you probably learned that, right? That acid plus base makes neutral. Turns out that's only true with this one. If I got a strong acid and a strong base. So here's the weird thing. For the one we just did, I had that. So probably it is about 7 now, right in here. And interestingly enough, it's still a tiny bit warm. So it's a little thermic, exothermic when I do an acid plus a base. But it's not going to always be that way and be exactly 7. If I have these other 2 cases, as you can see, if the acid's stronger, it becomes neutral, oddly enough, at a lower number. If the base is a strong base and a weak acid, it becomes neutral at a higher number. We'll see why that is. I know that sounds weird. No B.
With the breathalyzer, I thought a breathalyzer, maybe I'm thinking the wrong thing, but I think you breathe into it.
Yeah,
So
exactly.
how can it measure your blood alcohol content without an actual sample of your blood?
Because it uses it as a gas and does the same thing. So it's a machine that can use it as a gas. And with whatever, the pressure, the concentration of the stuff you exhale, there's a direct relation with what you exhale and what's coming from your bloodstream.
Oh, okay.
So that's
Like
why.
biological.
That's why. So it's not actually taking the blood, but it gets an indirect, but very accurate, as it turns out, representation of what's in there based on your exhaling. No D.
but since we use phenolphthalein and the endpoint for that is 9 to 10, doesn't that mean that?
We screwed up.
Yeah.
But we didn't. And thank you for noticing that. So you might think we screwed up, and I'll show you why with a graph, why if it's actually a strong and a strong, I can use any of the 3, it doesn't matter. But only with a strong and a strong, and we'll see why that is. It's a good observation, Noah. Thank you. Okay, good. Any other questions or comments or observations before we continue? No B.
So when it says that the color, here at the definition of the endpoint, when it says the color changes, it's changing from pink to neutral.
Yeah, it changed from pink to clear for phenolphthalein.
Okay.
For different ones, it changes to different colors.
Okay.
And they would tell you that on the AP. You don't have to memorize that, okay? They'll tell you, like, this one is at a low pH, has this color, at a high pH. You don't have to know those, all right? But the 3 that are typical in like a multiple choice question that you do have to know is methyl red, bromo blue, and phenolphthalein. Okay, just as to where they are. So we'll need to like put that to memory. So my cat does sometimes, sorry. Okay, so let me move that over to the side here before I break it. So I don't want to do. So, yeah,
Wait, so you said that you can use any of the indicators only for strong and strong?
yeah, we're going to see why right now. Okay. So let's talk about strong titrations. And by the way, Cheryl will not teach you that M1, V1, M2, V2. She hates it, but you're welcome to use that unless it's got like, what would be the problem here? What if I use H2SO4? Why does that make it more difficult? H2SO4, so to speak. Aaron? I got two H pluses coming off. That's a problem. Or what if I had BaOH2? Then I got two OHs coming off, right? You can still use the M1, V1 thing, but it's harder because you got to throw in a 2 somewhere, and you really got to think about where to put in that 2. If you're good, you can do it, okay? But if not, use the Cheryl method that she'll teach you in chapter 6, okay? So don't get me wrong. She's great, so you can use her method too. Okay, so we've kind of already done strong problems when we talked about acids and bases initially in chapter 5. So I'm not going to spend a lot of time on them. Strong acid, strong base, titrations. Okay. We know the end point is where the color change happens. The equivalence point, we had this, but it's been a long time ago, is the point where the reaction is complete. What does that mean? Let's do a reaction for the one we just did, and you'll see what I mean. Okay, so NaOH plus HCl forms, well, maybe you know some of this. Can you guess? How about my Schnupper friend? So if I had an acid and a base, do you remember one thing that forms in general?
Water.
Water, good. And that's why it heats up, everybody. When it warms up, it's because I'm creating water, and water is very low energy, you might remember, as a molecule, so the energy is given off as the new bonds form H2O, okay?